All right, everyone. Welcome to Monday, MedChem. Congratulations to anyone who likes the Rams. Did you party all night? Does anyone like the Rams? You're close. Everyone's still upset about Arizona. I know. I was too. All I heard during the Super Bowl was the Packers got beat a lot. That's what I heard, but that's okay. Anybody on Zoom? Rams? There's no Rams fans in here. Any Bengals fans? Yeah, I bet on the Bengals. They let me down. Cool, Joe Burrow. It's okay. No problem. Obligatory boo to sports. That's okay. It's you'll probably stay healthier if you just don't like sports in general. I stay upset all the time. Anyway, so what I figured out we would do today is actually talk about sort of all the projects that are going to be going on throughout the rest of the semester. It used to be talk about a project and then it'd be like a due date and then talk about another project later on. And, I figured we'd talk about all of them. There's sort of a new one that I want to introduce this year that I think would be cool. I try to introduce a new one each year as well as do the old ones. The reasons for doing some of these projects too, so that you guys don't have to just take quizzes. I mean, to me, just a quiz is sort of boring, and I'd rather you guys go learn something about the real world to get, become more well-rounded individuals. So the first thing I was going to talk about was going to be the project for the honors contract. So I'm going to go ahead, share the screen. For those of you waiting on your exam anxiously, Abesh is pounding through those. Hopefully we'll have those to you shortly. I would also like to apologize for those reviews. I forgot to take it out of gallery mode, so you probably couldn't see what I was writing. That's my bad. I'll fix that in the future. I was informed of that. Anyway, so how many of you guys are taking doing the honors? Yeah, a little bit. Cool. I got a list of names now, and I'm going to send those names out via an announcement just to make sure that I have everybody that I need to through the Honors College. If you're taking it through the Honors College, I approved everyone that came through. And I think there was somewhere in the neighborhood of 12, 13 people, which is good. Yeah, I mean, so the project, in general, this is actually, just to give you a little bit of history on it, this was actually started by, we hit the pandemic not too long ago, and we couldn't go into the lab. And so one of my actual undergraduates sort of spearheaded this idea to, what if we can come up with something cool to sort of familiarize ourselves a bit with MedChem, but it'd be something that you could learn a little bit of the software used and sort of design, drugs, right? I think that was sort of neat. And so we came up with this idea. It's called Explorations in Metabolic Biocatalysis. As you guys know, I do biocatalysis in the lab. And yeah, so it's sort of an interesting way to introduce you to biocatalysis, and in particular, the biocatalysis that's going on in your body, right? It's pretty cool. And so you have a little bit of explanation up here, sort of about the project. Talks, sort of the considerations, anything from sort of design to ADME, to sort of excretion of the drug, which I think is really neat. Some of the things you'll be doing is familiarizing yourself with the chemical communication software ChemDraw and molecular visualization software Pymol. How many of you guys have used ChemDraw before? Cool, a few. So you got some buddies. Okay, Pymol is probably a little more popular, right? Okay, cool. Yeah, so we'll give you directions as to how to get those things and sort of talk about those in just a minute. What you're going to do is you're going to choose a metabolic enzyme to explore. So the reason why we have this conversation now, right, is because you've now seen sort of what I would say is the majority of the metabolic enzymes you'll be exposed to, right? P450s, the flavin monooxygenases, right, glucuronyltransferases, et cetera. And a host of those have been deposited to the protein data bank. Have you guys ever used that? Some people ever visit there? All right, cool. So this is kind of an excellent database of sort of all the crystal structures of proteins that have been crystallized with or without their sort of native substrates, and sometimes with their unnative substrates, which I think is pretty cool. Definitely go explore that. It's a really, it's a free site to explore. You pretty much can type in any enzyme that you've heard of, and you'll get a crystal structure of some sort, which I think is really neat. And then sort of towards the sort of end of the project, you're going to propose regulators of the metabolic enzyme based on what an analysis of the active site looks like and what you've learned in lecture. And so it's a nice way to almost become, right, a medicinal chemist in sort of a shorter period of time. Some of the core responsibilities affiliated with it are going to be this 2-page report on a metabolic enzyme target that's going to include some background information on the enzyme, clearly presented depictions of the metabolic regulator or small molecule bound to the target using PyMol, a structural analysis of the active site, so sort of what you guys have seen before, where you have sort of a series of residues, put a molecule inside and say, okay, these are the key interactions that sort of come into play in its binding. A proposed chemical strategy for increasing the binding, right? And so those have been some of the things we've been talking about. We'll continue to talk about them throughout the course. So I would say sort of this is one of the types of projects you want to work on sort of as you go and as you learn a little bit more in the course. I would say you guys would be fully equipped to finish it probably about a month from now, maybe mid-March, I would say. It's due April 15th. Everything we talk about today is going to be due right before class on April 15th. By the way, I also wanted to sort of streamline that for you guys, so you just have one date to think about in terms of those things being due. A proposed new class of compounds for future structure activity relationship studies on the target. SAR studies are going to be things that we talk about probably in a week or two from now. So you can pump the brakes on that. But I would say sort of in the early go, you probably want to get ChemDraw and PyMol on your computer. I've set it up such that you have what would be sort of an educational version of PyMol that you can download and play with. It's actually really I think really cool opportunity for you guys. And for people that aren't doing the honors project or graduate project, this stuff is also open to you to go and explore. If that's something that you're intrigued by, feel free to do it, sort of, on your own time, or if you want to do this after this inspiring conversation, you can also tell me. And then the second thing is going to be a 5-minute recorded PowerPoint presentation of your findings. And I'll give you sort of an example of what that looks like. What you'll do is you'll create sort of a deck of slides, sort of present sort of what is presented in your sort of 2-page report. And then you'll go ahead and sort of record that, so it has a little bit of life to it. So what we'll do with those is I'll likely post them, and then some of it I might point to 1 or 2 of them that might be information that might be asked about on your final exam. So that way, sort of you definitely want your work to be watched. I know it's a little like, yikes, I don't want people watching videos of me, but I would say just it's really neat. I think the work that goes into it ended up being really exciting. In fact, one of the folks that tackled one of these last semester is now turned into a provisional patent. Sort of through sort of the design the sort of design approach they took. So really neat. I'm not on that patent, just so you know. I won't take any of that stuff. But very cool to see that sort of happen when you dive into this thing. Right. So in order to begin the assignment, it will require you download ChemDraw, this chemical communication software. You can go ahead and download it at the link below. And then PyMol sort of has a series of information affiliated with it. Details on how to download the educational version and other details can be found in the appendix that's attached to the sheet. Instructional videos on details of how to download and manipulate crystal structures from the PDB are posted in the MedChem YouTube channel. Those will be up. We're just updating those now. So the student that sort of spearheaded it, she created sort of instructional videos as to how to download it, and then also how to use it and get sort of nice videos or nice sort of depictions of the active site or binding site of the enzymes. Really neat. Some further details, sort of these are sort of a little bit more guidance affiliated with the project. Sort of choosing your target enzyme, right? You can select one of the metabolic enzymes that we covered in class, and choose a specific example that has a known crystal structure. Then you'll know that by searching that in the protein data bank. And while it's not required, I would suggest you choose one that's been published with and without a ligand attached to the active site. And so that ends up being important if you can find one, for example, a keto reductase that has a compound bound versus one that doesn't have a compound bound. So then you sort of get a feel for what sort of the induced fit almost looks like, sort of in the binding event. If you can't find one, that's okay, and you'll be able to, go throughout the project without it. But you'll definitely find there are certain metabolic enzymes that there's a ton more of them versus some other ones. For example, cytochrome P450s are going to be everywhere. Keto reductases, alcohol dehydrogenases, the flavonomonoxygenases, there's a ton of those. When you get into ones that are like glucuronyl transferases or sulfotransferases, those are super interesting if someone would take one of those on. There's just not a ton of those that have been sort of crystallized or have crystal structures. In the background, it's likely that the selected enzyme will be affiliated with a paper. That's sort of where I would say to take your content from in terms of sort of what the significance of the enzyme is. The depiction of the metabolic regulator, yeah, it's time to become a true medicinal chemist, and dive into the active site of the enzyme. So you'll use the PyMol visualization software. You can provide sort of an analysis of the enzyme active site. So you say sort of what are the key binding residues, sort of what sort of spaces in the active site you think you could take advantage of if you were to design a new drug, etc. And what we'll do too is we'll meet. I'll probably call sort of a separate meeting once or twice between now and of course the 15th, which I'll ask, how are things going? What are sort of the challenges you're seeing, and see if I can provide some guidance. Right. So you want sort of these labeled measured snapshots in PyMol. Those are basically going to show sort of for example, hydrogen bonds or van der Waals type interactions, etc. And you're going to be able to sort of measure what the distances look like in the active site, sort of for a compound that's bound. And again, the tutorial videos take you through sort of how to do all this and how to display it really nicely. And then you get into sort of thinking about how you go about strategizing for increasing binding. So we've thought about some different strategies, and we'll talk about them in a little more detail. You'll provide a description of what strategies we've covered in class that might be used to increase binding. One of the most popular ones is extension strategies. So sort of installing something on the molecule that is going to allow you to sort of access new space in the active site and hope sort of create better binding, for example. Coming up with isosteres, we'll talk about those a little later. sort of they're like almost replacements of functional groups in the molecule that sort of are about the same size, but they, let's say, introduce a hydrogen bond or something along those lines. And then propose new analogs that you'd like to screen to save the day. So sort of better binders, right? As long as you use sort of your logic from what you've learned in class, right? That always goes over really, really well. And then ultimately, you're going to take sort of your knowledge of the formecrophore affiliated with the molecule, and you're going to create sort of a whole new class of compounds that you would consider. So almost like it's that step right before, you know, everyone goes in the lab, having that big meeting and saying, you know, okay, here's some compounds that we think would be really cool to use against a target. And so it sort of really gives you sort of the full gamut of being able to sort of experience what it might be like to be a medicinal chemist. As you scroll down, this thing takes you step by step into getting PyMol. Accessing ChemDraw is usually pretty straightforward, but I would maybe start a sort of Discord discussion on that. If you're having a challenges affiliated with that, you can also start a discussion. I'd be happy to talk about that anytime. So here's some of the details. I think probably in about 3 weeks or so, I'll sort of give that reminder that says, you know, should definitely, you know, get started on this thing and make sure that you have access to PyMol and you played around with it a little bit. I would say ChemDraw is pretty, at least, you know, decently straightforward to use. Which if you play with it for about an hour, PyMol probably requires a little bit of time with the videos to really sort of orient yourself in certain sort of positions, you know, at the end on the enzyme. So you're probably going to want to take, you know, a little bit of time and do that. It's a lot of fun, and hopefully there's going to be a lot of know-how as you guys get going. That's another really great thing to do, is, you know, sort of make that a discussion either in Discord or on Canvas. Are there any sort of general questions? I'll show you an example in just a second. I think there might be a question here. Woo honors, okay. Yeah, if you're not an honor student or a graduate student, you do not have to do this. So you should know by now if you're doing this. Graduate students, you're locked in. Part of your responsibility as a grad student.
We have like a shared spreadsheet that like how we calculate like which one, like which like enzyme, like we're late students, so we don't have to have both or anything like that.
Oh yeah, that's a smart idea. Yeah, so I'll go ahead and start a discussion actually on Canvas. Then you guys can sort of, you know, claim them. So what was suggested for the Zoom folks is that we create sort of a list, right, of the enzymes that are being used, so you all don't do like, you know, the same cytochrome P450. That'd be a snoozer for the class. So you guys can sort of, you know, go on to the discussion. I'll create that tonight, and you guys can you can go ahead and sort of claim the enzyme that you'd like to pursue. You don't have to rush too much. If there's a couple overlaps, that's okay. That's no problem. That's a good question. So everyone okay? That's doing that, to dive in to this a little bit. It'll take a little bit. I mean, the questions will naturally come up as you get going on it. And no one tried to dive into it yet, right? No one wants to say so. If you guys have questions, you feel free to start discussions or send me an email or whatever. That's fine. I wanted to go over to just talking about the global health project, if we're all wrapped up with this one. So just to give you a little bit of history on sort of the Global Health Project. This is, oh, actually, I just want to show you a quick couple examples of, or example of the metabolic biocatalysis project. This is sort of what it looks like. It's sort of 2-page form. So right, there's a background. There's a little bit of sort of analysis of the active site, of the binding site, the molecule bound inside. It talks a little bit about sort of, takes another sort of approach of the, sort of looks at it from a different angle, or maybe one that's sort of bound to another molecule, for example. And then this is where they sort of outline, right? This is something you guys have seen before, where they outline sort of what the sort of core binding residues are, and maybe another depiction of sort of what that looks like, almost if you were to map them on to each other, which I think is really neat. And then there's sort of these strategies to increase binding of the molecule or the ligand, and sort of we'll get into talking about this as we move throughout the semester, but talking about sort of different strategies, so these methylations or sort of ring fusions that he uses. So this is sort of I would say these are sort of like type of extension strategies, right? Putting sort of hydrophobic groups on to sort of increase van der Waals interactions, for example, or these start to ring fusions where you can start to use sort of rigidification to sort of make sure it's sort of keeping some of the functional groups in place. This one, of course, is a big greasy molecule, so it's not maybe as exciting, but then sort of ring variations, well, those will be something we'll talk about a little later, and chain compressions or elongation, so making it larger or small. This is something that came up with. And then sort of this pharmacophore analysis goes through, talks about sort of the non-polar side chain and aldehyde ester, for example, which I think is pretty cool. And then he designs some new ones to use, right? So this is very sort of representative of what that's going to look like. And I'll also post this once he just wants to modify one quick thing on it, and then I'll post it as an example for you guys. Then heading over to what maybe the talk might look like. Sort of just a nice title slide, talks a little bit about the background, sort of what it does. Talks about sort of the cofactor binding site. So that's another thing that'll come into play. Something that if it's NADPH dependent, for example, those would be like ketoreductases. You'll talk a little bit about that. And then talking about sort of the active site, and this is sort of one with the molecule bound. Talk a little bit about sort of what the key binding residues are there. Sort of zooms into it a little bit. It's very colorful, but really nice sort of depiction of what things look like. And then sort of schematic, right? So like you saw previously of what the binding site looks like. And then, he talks a little bit about sort of the strategies he's going to use, right? So it maps on very well to his paper, and of course literature references and stuff. I'm not too picky on how you reference things. I would say reference them appropriately. If you want some guidance on that, I'd be happy to talk to you about that. So we spent a lot of time, this is moving on to the Global Health Project. We spent a lot of time talking about sort of health from a sort of medicinal standpoint, but sort of as things have progressed with the pandemic, et cetera, among the numerous pressures that that are put on you guys on a daily basis. This is an interesting time to be an undergraduate, graduate student, faculty. So I think it's important that you take some time and think about sort of nonprofits, for example, that are thinking about being able to help out sort of on global health in general. And so one way of highlighting that was to sort of assign you guys something where you could go out and look for a nonprofit type organization that's doing something really cool in the world. It sort of, helps with, sort of overall global health, right? That's definitely, broadly defined. And so people sort of went out. This is a really, really cool experience last time. You could see there's 484 pages of this thing in one class. And they went out and they look for organizations that they think are doing something that's really cool that's helping out sort of humanity. And so what they do is they sort of go through a five or so slide deck of just sort of outlining it and sort of how to get involved. And so, for example, this 1,000 days is a really, really great one. Talk a little bit about the leadership, where these people are coming from. That's always important, right? When you're thinking about organizations like this, where they come from, what led them to do whatever it is that they're, what they started. Talk a little bit about what it is, 1,000 days. Get into a little bit more of the description. Right, it takes you 1 or 2 slides to get into each of these things. That's fine. And then sort of the core missions and the goals. So not only want to know about what they're doing, but also how they're doing it. Right. So, it's really easy to say that, I'm gonna, I don't know, right, do something, but I want to know sort of how it's being implemented. And so, giving a little bit of information on that is really nice. Core initiatives that they're focused on. So usually they outline, 2 or 3 of them that they're interested in, and then ultimately how to get involved. And so, ultimately, I haven't really started to do this yet, but what I really like to do is continue to collect sort of the, the range of them that are sort of, popping up, throughout the world. And at some point, I would really like to have, a full blown database where, all your contributions sort of go onto that database, and inform people of all different types of initiatives that are going on. I was blown away at how sort of inspiring this. So eventually, what we'll do is we'll meet for a class period. This is worth 75 out of 100 points. The other 25 is going to come from your participation in the discussion. That means just sort of being there, and we'll chat about anyone who's sort of really inclined that wants us to know about the organization they chose can speak up, and we can talk a bit about it. It really led to, I think, a ton of great discussion, and I think it was a really sort of heartwarming day. I think really, 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 really neat. So this is something that also is going to be due April 15th. This is for everyone in the course. And the one stipulation that I have with it is it can't be an organization that's already been done in the class. So once you pick one, flip through this document and make sure it's not covered. If you're really passionate about something, you want to cover it again, or you want to give it an update or something like that, I'm fine with that too. There's been a ton that has sort of come up for over the course of the last year to year and a half. Any questions about that? Yeah. Yeah. So I want you guys to take like a week to think about what one you want to go after. Last time, what I did is immediately after class, I put out a discussion and it turned into a battle. I mean, people were just already had. So why don't you guys take the rest of the week, and then Monday after class, I'll post it on the discussion board, and then you can start to claim them. Because I think it'll be too hard right now with the ones that have already been done. So I would give this some thought this week if there's something you're really passionate about. It's a great question. Any other questions? Some in the chat. Yeah, I mean, if they're a research, if they're sort of a research, type of institution, that's fine with me too. No problem, Elijah. It's very broadly defined. So just something you're passionate about. I don't like giving you guys assignments you're not passionate about. That's, it's not a good time, right? Um, so I want to briefly talk about any more questions. I want to briefly talk about uh, the final idea, and this one's going to be for 50 points. I'm big on sort of you guys contributing to sort of the next generation, right, of medicinal chemistry students, and I always try to create something that's sort of educational for the next crew. And so, I thought it'd be a really neat idea. And sort of I also run this by, medicinal chemists in the field. And one idea that we came up with is creating a TikTok like medchem medchem haiku. So so it's a nice way. I've never taught a poetry course, so this will be the first one. But I thought it'd be cool if you guys could come up with sort of a nice, clever way to sort of present a topic or a drug or something related to medicinal chemistry. So one thought that we had right at the beginning was just to pick a drug, write a haiku on it. I think that'd be really neat. And then get I don't know. I don't know how many people. It sounds like there's not a lot of TikTok users in here, so that's okay. But I thought we maybe could get sort of a bit like sort of theatrical and cool with it. This is something that again I would like to try and share these, sort of with the chemical community, et cetera, right? And get you guys involved in that a little bit. Of course, that's at your discretion. But the thought process would be to create something between 15 and 30 seconds. Nothing, it doesn't have to be an hour thing, but come up with, write a clever haiku about medicinal chemistry. A topic of your choice, really. If you do want to just pick a drug, that's fine. And then sort of find a nice way to present it. Sort of, I don't know. You guys can use your imagination. I'm anticipating you guys are much more creative than I am. And sort of, I would like to enjoy TikToks of people that I know. If you guys do not want to download, I will say this on recording. I downloaded TikTok for the first time last night because I gotta live it if I'm gonna assign it. And yeah, that thing's addicting. And I don't like that it's addicting. So it'll probably get out of my life soon. But for now, if that's something you guys want to do, go ahead and download it and create it on there. You can also create a video that's independent of TikTok. You don't have to be affiliated with that. But I know TikTok conveniently sort of has the convenient filters, or I'm still learning. I made one on accident anyway. But yeah, get creative with it. I think it'd be really cool to sort of see what you guys come up with. That's not going to be one that I create a discussion about and you guys create your sort of call a topic or anything. You guys can feel free to do whatever topic you'd like. But I don't know, you might want to pick your favorite amino acid. Just kind of thinking some interesting favorite amino acid, maybe favorite type of company, drug, an enzyme that you think is really cool. Anything along those lines is perfectly fine with me. But that'll be 50 points, and again, that'll be due April 15th. Do you have to show your faces in the tech? No, you don't have to. Not at all. I'm totally fine with you guys creating something that's, no, your face is not necessary. Just some medchem. Any questions? In starting this, who would get a TikTok to do this? Few. This group is anti-TikTok. It's, you know what? It's probably the healthiest to not dive into TikTok, but but yeah, create at least some, like, you know, just a short clip where you present your haiku. I think it'd be a lot of fun. I would like to, you know, have some fun with it and share at least a few of them during class. That sound okay? Decent for 50 points? Is it worth 50 points? Thinking about it? Some head bobbing. Well, that's all I have to share with you today. That sort of outlines the 3 projects. They're all due April 15th. If you have questions, send me an email, start discussions, etc. That discussion board is silent. Get loud. Cool. Cool. Yeah, I mean, the way that you get points docked on the TikTok assignment is like, you know, you guys know what's sort of lame and what's not, right? Don't just come out and be like, oh, here's this dumb haiku. Goodbye. You know, do something that's a little creative. I don't want to give like those really creative people like the 50 points and then like someone who spent like 0 time on it, give them 50 points as well. Right? Get creative. Spend a little time on it. Cool. All right. You can turn it in via email. I don't really care how you get it to me.